Hi everybody, in this video we're going to talk about your level 1 dilations and similarity worksheet. I know the last video did not have audio, so hopefully this one does. Just a reminder, so if we have, now that we're looking for similarity, we are going to be looking again at our different similarity statements such as SSS, SAS, and AA. Okay. Now, these are similar but different to our congruency statements. When we were looking for congruency, we were looking for sides that are exactly the same length. Here, for similarity, to have the S evidence checked off your side, we want sides to be proportional. And what I mean by that is if I can take one of the lengths of our dilation and put it in fraction over the corresponding original length and set it equal to another length from my dilation over another length from my original that corresponds. If they're equal, then they're proportional. So that's how we'll be figuring out some proportional sides here. For our angle, my A evidence, we still want angles to be congruent, exactly the same measure, okay? So on the first video, we did walk through a few of these, but here it is with audio this time, hopefully. So the first one, we did note that we have not similar because of the fact that we have angle R and angle K congruent. However, angle L has 2 congruency marks, angle Q has 3 congruency marks, and angle P has 4 congruency marks, meaning none of the other angles match up. I only have one angle for evidence, therefore it does not suffice for either my SSS, SAS, or AA. Okay. Number 2, I do have these 60 degrees that are exactly the same measure. So angle E is congruent to angle U. That's one angle for evidence. And then the other portion that we are noting, because these triangles do intersect, we have created some vertical angles. We know that vertical angles are always congruent. Okay. Therefore, I have the fact that angle ETD is congruent to the angle VTU. So that is my second evidence for AA. And that's all I really needed for this angle-angle similarity. Now talking about the order in which we write my statement, okay, it does have to be in the correct order, corresponding parts. So T, U, V. I'm going for my vertical angle T. So on my other triangle, I am going to start at T again. I'm going down to my 60-degree angle. So on my second triangle, I'm going to go up to my 60-degree angle, which is E. And then finishing off with the last angle D. Okay, so in this case, number 2, triangle TUV is similar to triangle TED. Now let's take a look at these other ones. Okay, I also did numbers 3 and 4 in the last video, so let's skip ahead and look at numbers 5 and 6. These are a little more different. We have a little more information about my sides here. And in another class, we talked about how figuring out these similarities might be a little bit of guess and check, because you'll have to guess to figure out which sides are the ones that are corresponding, since we don't really know, and then we're going to check. Sometimes your first guess might not be the correct one, and you'll have to check another instance. So start with going your gut feeling. In this case, we can kind of go along with kind of the patterns that we see in these numbers. So thinking about 130 is my largest side on this triangle, okay? On my other triangle, 60 is the largest side. So most likely, if anything, those are the 2 ones that have to correspond. And then let's check with the smallest length. I know that 36 here is my smallest length on this triangle, and 78 is the smallest length. So if anything, those are the ones that are going to have to correspond with each other. And obviously here, number 5, we have only information about my sides. So if this is going to be a similarity, it has to be an SSS or might not be similar. So let's check. We check with our proportional sides, remembering by setting up my dilated side over my original side. So we're going to use my larger side or my larger triangle as my dilated over original and set it equal to another set of sides. So I was saying 130 has to correspond to my 60 because those are my longest sides on my triangles. And if it is equal to 78 over 36, which are my shortest sides on my triangle, then we probably have these proportional sides, which leads us to proportional or similar figures, similar triangles. So let's double check. If I do this, then remember, fractions are the same thing as division. So take out your calculator, we'll do 130 divided by 60 and check if that is equal to 78 divided by 36. All right, so if you got the decimals 2.16 repeating and 2.16 repeating, noting how these two decimals are exactly the same, so there is no question anymore. We do have proportional sides. Therefore, I know that this KL side has to be similar. I'll use that similarity symbol instead of the congruent because they're not equal to my DC side. The JL corresponds to my EC. And then finally, the KJ must be corresponding to the DE part. Okay, so let's make our similarity statement here. I have triangle LJK, 1, 2, and 3. Similar to the triangle, so the 1, 2 side, my LJ side is the short side, 78. So that is corresponding to my CE side. Okay, note how I am saying it CE instead of EC because of where it's going. Okay, 1, 2, 3. My 78 goes to my 104. My unmarked piece, the 48. So I will be going to C, E, D. Okay, so practicing where would we have these correct orders? How would we align those in our similarity statements? Okay. Let's also practice with our next portion here. It says to find the missing length, the triangles in each pair are similar. So we've already been told that these triangles are similar. There's no guessing anymore. We just have to find the missing length. So let's look at some of the ones that are probably a little harder here, where we might have to guess. So let's try out numbers both 13 and 14 here. So 13, they didn't give us a similarity statement because these triangles are kind of nested within each other. So that means that this DW side will correspond with my DB or 60, okay? And then my 44 DV will correspond to my missing piece here, DC. Okay, so setting up my proportions in order to solve for the missing side. Again, we'll use the dilation over my original. So I have 60 corresponds to my 48 is equal to my unknown length over 44. right? Once you get a hang of this pattern, setting up these equations, all we have to do is straight algebra. We want to solve for x, so I need to isolate x. It's currently being divided by a 44, so I need to undo the division by multiplying by 44. This now leaves me with a 44 times 60 all over 48 equaling my unknown side. Now again, no worries. Go ahead and grab a calculator if you need to. We're going to multiply 44 and 60. Once you've gotten that in your calculator, you should end up with a 2,640 over 48. Now that's left is the division piece. We're going to take 2,640 and divide it by 48 to get our unknown length of 55. Okay. Here, let's also practice one more time ordering our parts. So DCB 1, 2, and 3 is going to VUT as 1, 2, and 3. So corresponding sides, my 1, 2 side corresponds to this 33. So I have an unknown over 33 is going to equal my 98 2 to 3 side over this 21 2 to 3 side. Okay, same deal. X is being divided by 33, so I need to isolate, cancel out my division by multiplying. So X will equal 98 times 33 all over 21. So we're going to get our calculators again and multiply my 98 by 33. Now that we've multiplied, you should get the total of 3,234 all over 21. Now again, fractions, same thing as division. So we're going to divide by 21 to get a grand total of 154. So my unknown side here, X is 154. Let's talk about the very last portion of this worksheet. Again, this is from level 1. You'll also see it in levels 2, 3, and 4. Graphing the image of the figure using the transformation given. So we're seeing this word dilation. We're seeing this number here. And this number just links us back to that problem that we did last week, Friday. Also on your Canvas page here, this is your scale factor. So what we're doing is taking our coordinates and multiplying by my scale factor, whatever it is. Now, number 15, we're just multiplying by scale factor of 2. So I thought multiplying by scale factor of 1/4 might be something you want more help with. So the first coordinate here, t, we've got a 1, 2. S is at a 2, -2. U is at a -1, -2. Okay. Now remember, when we're taking this dilation, when we're multiplying by my scale factor, I just have to take that and multiply by my coordinates. So t, when I take my t prime, my dilation, instead of 1, it is now 1/4. Instead of 2, it is now 1/2. Okay. You can do this in fractions, or you can do it as a decimal. Note that multiplying by 1/4 is the same thing as dividing by 4. So if that's easier to do in decimal form, you can definitely do that. It will end up being as a 0.25 and a 0.5, just so that you know both versions. S prime, instead of a 2, -2, I'm going to get a 1/2, -1/2. Decimal form, that means we will have 0.5 comma, negative 0.5. And then lastly, my coordinate u, my dilation or my dilated version with the scale factor of 1/4 is going to become a negative 1/4, comma, a negative 1/2. Decimal form, you'll see it as 0 or negative 0.25, comma, negative 0.5. So those are all the different sections that you'll have for this worksheet for you to practice dilations and also similarity.